So now we move on to loops, which in a way are much more sophisticated than if statements because it allows us to do something not one or zero times, but potentially many times. But the syntax for loops is almost as simple as that for if statements. And the simple form of this is the for statement. In its simplest form, it's the easiest of all. And we're going to start out by saying for, we give it a loop variable, in, that's another keyword, and then a collection, we're going to use lists here in this course. And then again, the statements, which must be correctly aligned as we've seen. What the for loop will do, it does something rather complicated in C, for example. It does something very, very simple in Python. What the for loop will do is execute a statement block one time for each element in the list. So in this example here, I have 7 different elements. They're all a number. The loop will be executed exactly 7 times. If there were 100 elements, it would execute 100 times. And what it will do very simply is it will take n and set it to the first element, which is 1, execute that statement, which is print n. Then it will set it to the second element, print it again, send it to the third element, print it again, set it to the fourth element, print it again, until we've come to the end. So conceptually, a for loop in Python is extremely simple. It's just run this for every single element in the collection, in this case a list. A variation on this, we can get a little more complicated here. This will be more familiar to you if you've used C or Fortran or BASIC or any number of languages. We can actually go through a list by using index numbers. As I'll explain later, you don't usually want to do this in Python. You want to usually do it the easy way. But if you want your code to be more C-like, or for some reason you need to use index numbers, then what you can do is you can generate range, which will be a list made up of integers, and then you can apply that as an index number. So we have the range function. Range n produces a list 0 to n minus 1. And that turns out to be exactly the same set of numbers we could use to index a list. So that's why we use range so often. You can also say range n to m, and that will produce a list from n to m minus 1. So a way we might use this if we wanted our code to look like C code, and the founders of Python would be perhaps a little upset if I told you to do that. But if you come from C and you want to do this, or you need to do it, and you want to write C-like code or Fortran-like code, what you would do is you would make a list out of range. So I'd generate a list of index numbers, and then I'd go through the list by indexing it. So that is something you can do if you need to. As we can see what the range keyword does here, if we say for I in range length B list, and B is 3, has 3 elements, then that's going to be the same as saying for I in 0, 1, 2, and then it will go through and index each individual element because of the statement as B list sub 1, B list sub 0, B list sub 1, and B list sub 2. So, but once again, if you don't need to use index numbers in your for loops, if, for example, you just want to print everything out in a list, then don't use this approach. Don't use ranges and don't use index numbers. Only use that if you have to. It's much easier just to say for I in list or for item in list or whatever. So remember, this is a little more like how C programs do things, and only use it when you really need to. So why would we want to use ranges in Python programming? What would be a good use for ranges? Now remember, range past the value 9 would give us all the numbers from 0 to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So what's a legitimate reason for using ranges? Well, let's say we want to print out a list of numbers in sequence. Well, the range would be perfect for that. If I say for I in range 9, and we say print I, and by the way, that needs to have parentheses around the I. But if we do that, what will it do? It will print all the numbers from 0 to 8. If that's what you want your program to do, that's what that little piece of code would do. There's also something called a factorial function. A factorial of a number is multiplying all the numbers from 1 to n in sequence, all the integers from 1 to n. That's a perfect use for a range. So we start with the value 1, and we multiply by each successive integer in the range 1 to n. Finally, let's move on to a loop that's conceptually even simpler than for loops. They do get a little more complicated, but conceptually they're really simple, and that's the while loop. This is the only other kind of loop in Python. Python's very simple, doesn't have a lot of variations. The while loop in Python is just while condition and statements. That's it. There's no do while or do loop or anything like that. Very, very simple. This little flow chart says we will test a condition. If it's true, we'll execute the statements, do it again. And we will continue to do this until the condition is false, and then we're done. Let's look again at the whole concept of what a condition is. In the simplest scenarios, a condition is going to be a test. We're going to say A equal B or N equal foo or something. And the simple programs will just have a test there that's either it's true or it's false, very simple. So that's really good coding, especially in beginning programs, because you look at it, you know exactly what it does. However, there are programmers, and Python does not stop you from doing this. Python does not discourage you from doing this. You can actually use any object as a Boolean. If you do it too much, you might create code that's efficient but difficult to read. But I'm going to recommend doing it for a few cases. So if you put in an object as a condition, if it is a non-zero number, it's true. If it's zero, it's false. And if we use a string or a list, if it is empty, it's false, but if it has any content, it's true. So here's how we might use this. We have a string that either has data or it's empty. And if we say if not s, do something, we're saying that as long as there is an empty string, then we would do that thing. So I said if s, do something, then we do something if there's any content in the string. But if I say if not s, I'm testing s to see if there's content or not. If there's not content, it's false, and then not false would become true. So remember, because not reverses the true-false condition. So let's see how this might work. Sometimes it's more convenient to do what's called an infinite loop. Why would you do that? If you say while true colon, it says always do this loop. Okay, that sounds crazy, right? If I say while true, always do this. It's never going to break. However, Python gives us a break keyword, and that break keyword allows us to exit the loop anywhere we want. And I found in programming, it's very often the case that putting the break in the middle of the loop gives you the flexibility you want. And sometimes it just fits the logic of the program. So I'm going to give you an example of this. Here's an incredibly simple little program. It's actually useful because I've written a version of this program in many different languages. It's incredibly simple. All it does is it allows me to add up a list of numbers. Now, I could use Microsoft Excel, but then I got to open a spreadsheet and I've got to set it up and I've got to do all this formatting. And let's say I just want to add up a bunch of numbers, or I could use a calculator, but then I'm not seeing the numbers all in a nice vertical column. I actually use this. I've actually used this on occasion. I write a little program like this, and what it does is I enter a number, I press return, enter a number, press return, enter a number, press return, and it finally gives me the sum. Well, when does it stop? When does it stop accepting input? There has to be an exit condition. Well, here's the exit condition. I say s equals input, enter number. S gets some text. If the text is empty, then the break condition will be enabled because it says if not s, that means if s is empty in effect. So I can enter numbers efficiently. I enter an empty string by just pressing enter. It will break the loop. Then it will go down and print the sum. So really simple program. I actually used it because it was, believe it or not, more efficient than opening up a Microsoft Excel spreadsheet. It's actually practical, believe me. So let's go ahead and enter that little program. So we have to start with sum equals 0. Now this is an assignment, remember. And we assign 0 to sum so that we can then increment sum. If sum starts out as undefined, we don't give it an initial value, then we're going to get the problems we saw in the first lesson. So we start out initializing it a value. We now put in our loop. Now, again, while true, colon, looks like an infinite loop, but we're going to break in the middle, so it's not really an infinite loop. It automatically indents correctly, so we keep that indentation, remember. So S equals input, enter number. Next statement, and now here we have a little bit of nesting. We nest an if statement inside a while loop. Perfectly fine. I can do this to any level. I can have an if inside another if, inside a while, inside a for, and as long as I have screen space, I can keep on doing it. And again, this may look a little weird because this condition is using an object, and not S means essentially if S is empty. And if S is empty, what do we want to do? We want to break. So that means we've got enough numbers. Now, if S is not empty, we want to add it to our sum. And we're using that combined add assignment operator. We also have to convert S. S is still text, so we have to convert it to a number, add it to the sum. Very, very simple. And if we're happy with this, or if Python's happy, it will just execute it. Okay, there we go. Enter number. And we'll just start entering numbers. Okay, we'll just start entering. And I can do this all day. And I can do negative numbers. And I can do fractional numbers here. So I just want to enter like a dozen numbers. And I could do this with a hand calculator, but I wouldn't see the numbers I input. I just really prefer doing it this way. And so how do I stop this? Well, as I said, it gets a zero-length string. It breaks. Boom. Did exactly what it was supposed to. Now, the only thing left to do is to print the value of the sum. So let's see it do that. Oh, and did it. Okay. See what's cool about that program? It actually does something useful. Very, very simple program, though. But it illustrates several things. It illustrates if statements, while statements, and it illustrates the break. The reason break is such a great keyword is instead of testing for the exit condition at the top, which is fine, I can actually do the exit condition in the middle of the loop if I want. Very practical. Now, I'm going to go on to another cool application. It's admittedly more cool if you're a mathematician and you've taken some math, but if not, at least bear with me. There's a very famous series of numbers in mathematics called Fibonacci numbers, and you start out with 1 and 1, and then each subsequent element in the series is simply the sum of the last two elements. So you go from 1, 1, 2, 3, 5, 8, 13, and so on. And this is like the coolest series of numbers in the history of math. All right, so if you're a math major, you're really going to get excited about this. If not, you're still going to see how powerful loops are. So in this case, what I'm doing is I'm going to write a function and have a while loop inside the function. So remember, we get a level of indentation that goes 1 over for each level deeper we go inside the program logic. And the first thing the definition will do is initialize A and B. They'll both be initialized to 1. And then we have a while condition that says while A is less than n, where n is the argument that we pass at the top of the function. And next we get a very interesting line here. This is called tuple assignment. Normally this would take several lines of code. If I wrote this in C or Java or most languages, it would take actually several more lines. I'd have to use a temporary variable, and it would be kind of messy. What this next line says, A comma B equals A plus B comma A. What that says is that A will get the value A plus B, and simultaneously B will get the value A. This will all happen at once, so I don't have to worry that the value of A is changing so that the value of A plus B is off, or the value of B changes so A gets the wrong value. I'm essentially doing A gets A plus B and B gets A. It happens simultaneously. So what happens, therefore, is that the new value of A will be the last two values in the series, and then B will bring up the rear. So B will be the last current value in the series. So this will make sense when I run it, hopefully. So now we're going to enter the Fibonacci function. And what this will do is it will print out Fibonacci numbers until they're greater than n. And so n will be any integer I want to input there. First, we initialize a and b. We now enter our while loop, which begins with the while condition. In this case, it is not an infinite loop. Remember the colon. It will indent another level exactly as it's supposed to. We say a comma b equals a plus b and a. So after the statement's executed, a will get the value a plus b, b will get the value a, and you don't have to worry that those two operations are going to interfere with each other because they're essentially carried out simultaneously. And then each time through the loop, we're going to see what the new value of a is, and a will be the current last element in the series. Now, I also put argument value end equals quotation mark space quotation mark. Now, the reason I'm doing this is because the default behavior of print is to actually put in a new line every time it prints. So it will print A and then put a new line. I don't want it to print a new line. I want it just to have a space between each of these prints. So we'll specify a new value for the end condition. So if I go enter twice in idle, it will say, do I like the function? Yeah, I took the function definition, no problem. So now let's feed it a number. So I want it to print Fibonacci numbers until they exceed 100. Let's see if it does it. Yeah, beautiful. Exactly. Did exactly what we wanted. These are the Fibonacci numbers running from 2 to 144. Once it gets past 100, it will stop. But I could do more. I could print Fibonacci numbers until they get to 2,000. And yeah, fine. There it goes. It does whatever I want. And you'll notice here that, first of all, there's a space, not a new line, between each element in the series. But also you'll see that this is how the definition of Fibonacci numbers works. 2 plus 3 gives me 5. 3 plus 5 equals 8. 8 plus 13 gives me 21. 21 plus 34 gives me 55. So this is the famous Fibonacci series. And the reason it's so famous is that apparently all of nature is somehow, or a lot of nature is based on this. All the patterns in a spiral, all the patterns in a sunflower are somehow predicted by the Fibonacci series all through nature. So it's the most famous series of numbers in math. And Python, we can actually write the shortest program possible to print out these things. So we've come to the end of a quick introduction to loops, but Python doesn't have a lot of different loop constructs. So it's pretty simple. We can use the for keyword very easily to step through a list. That's what it's designed to do. So for n in, name a list, and it will simply go through and execute a statement block for each element in that list. And each time it will set that loop variable to a different element. So that's pretty simple. The while keyword in some ways is even simpler. It's like the if statement block, except that with while, the statement block is executed again and again and again until the condition is not true. So it keeps going back up to the top and retesting it. And it's very similar to if, except again, you can just do it as many times as you want. Just keep testing the condition. However, sometimes we want to break in the middle of the loop, and therefore we can use the break keyword to exit earlier. So then you can exit from any place in the loop you want by using break. And that's why I spend so much time on break. It gives you that added flexibility that basically allows you to be as flexible and versatile with loops as you want.